is Michael Arnaldi. He's the host of the Practical Functional Programming with TypeScript workshop that you all get a 20% discount on if you're attending this meetup, by the way. And Michael is passionate about technology and its application in the financial industry and has extensive experience in leading tech projects such as trading engines, AML, KYC solutions, and payment systems. And as a technology specialist, he has a strong interest in several areas, such as functional programming, category theory, event sourcing, artificial intelligence, DevOps, and cybersecurity. Today, he will discuss how to write efficient and testable code using some of the modules in Effect TS. And after Michael's talk, we will host a Q&A session where the best question asked will win a free ticket to the Functional Programming with TypeScript workshop that Michael is hosting. And the winner for that will be announced at the end of the meetup. So be aware, watch Michael's talk, and think about a good question that you can ask in the end so that you can win a free ticket to his workshop. Without further ado, let's bring Michael to the stage.
Thanks, Nick. Pleasure to be here.
Hey, Michael.
To be invited
yeah,
to speak.
To see you up here. All right. We are about to enter your talk, but maybe I thought that you could just say one or two sentences about the workshop that you're going to host so that people already can know what they can expect and are hopefully a bit more motivated to ask good questions.
Absolutely. So in the workshop, we will basically go through all the basic principles of functional programming. Some of those principles are, in fact, what we speak about today. And in general, we will see what is thought to be a practical approach to functional programming. Functional programming in general has at least two different interpretations. One focuses on the mathematics side and on the theoretical part, and it is definitely a very interesting topic, but when it comes to writing applications in that style, it's not so obvious how to apply the thing. And also for most developers, the namings of things that are used in the theoretical side don't quite reason if you don't have a mathematical background. Right. And I have a mathematical background, and I can tell you they don't reason with reality, even if you have a mathematical background. So we've done a great job of simplifying things, thinking in the optics of applying those principles on the everyday applications that we write. As a matter of fact, I've ported a whole ecosystem that is Zio in Scala, that they have done this job for the Scala language, and I've done that for TypeScript. So that's a very funny thing, because learning one of the two technologies actually enables you to apply both of the technologies in two completely different environments. So that's what we'll talk about in detail in the workshop, and
very nice.
We'll go through practical examples, and it's all interactive.
So making functional programming approachable for folks that haven't really been in touch with that. I really, really like that. I'm also a big fan of functional programming. I remember having spent a couple of days with Haskell, and it felt like learning programming all over again. But all right, enough about functional programming, at least for now. Let's get started with your talk, Michael.
Yes.
The stage is yours.
Is the screen okay? Good. So the talk is called Write Testable and Efficient Code with Effect TS. What do we mean by testable code, and why the keyword efficient? Usually efficiency and testability are thought like counterposed things. Something is either testable or efficient, but it doesn't have to be that way. Things can be really efficient while being testable if architected properly. So this talk is about to share some light on how to achieve that. First of all, what do we mean by testable code? Testable code is code that is written with testability in mind. So it's code that when it boils down to writing tests, it doesn't present the classical issues that we all know. Testable code is a broad term and usually encompasses a set of common traits that we can find regardless of the pattern we are using, of the language we're using, and etc., etc. Those traits are modularity, single purpose, explicitness, low coupling, separation of pure and impure code, and simplicity in general. Is good code. It's easy to write and it's easy to maintain when wrote with purpose. When we write testable code in the wrong way, it's a mess of spaghetti code that doesn't really make sense and impacts efficiency and impacts everything else. Functional programming, we spent a few minutes talking about functional programming before, and here I want to highlight some misconceptions about functional programming. Some people are saying functional programming is testable. Write functional and your code will be testable. Well, that's false. If you write functional code without testability in mind, it's going to be as hard as any other paradigm when it comes to testing. What functional programming sort of brings together is instead some other traits like the single purpose of functions, the separation between purity and impurity. So functional programming by default has some of those traits, but not all. And this talk is going to be about a design pattern that enables for testability while being purely functional with preservation of efficiency. We're going to do that first by hand, and at the last part of the talk, I'm going to introduce the Effect.js library that I've said before it contains a port of Zio. That's a Scala library for doing pure functional programming, and it's implemented for TypeScript and in TypeScript. It is extremely efficient. It uses very low allocation, and it's really, really fast. It's generally 4 times faster than promises, and not that is important for everyday application, but this is a proof that you can be safe and fast at the same time. The price to pay is, of course, learning a new paradigm of programming and be strict about what you do. So let's take a look at an example that most likely everybody here already saw. It's the very first function that every programmer looks at. It's the hello world function that when it's called, it prints out on screen hello world, followed by whatever input we provide. So what's wrong with that? It's funny to see that the very first example of a function we see actually contains a lot of wrong things. First of all, it's not even a function. Why it's not a function? It's not a function because as soon as you call the procedure, that's the correct name for that thing, as soon as you call the procedure, a side effect is performed and a global state is mutated. People say, yeah, this doesn't mutate any global variables. That's false. It mutates the state of your screen, the state of the console. That is a global state. So that function is not pure. So it's not a function in the mathematical sense. The function doesn't return anything meaningful. In fact, if you check the type, the return type of this function, of this procedure, I should say, it's going to be void. And when we have something that returns void, we have no idea if by calling the function, we could end up with an exception. And that boils down, in order to know that, you have to see the implementation. There's no other way around. And when you have to look at the implementation of something to know how it works, to know what's the possible result is gonna be, then you have problems. I remember the same experience in Golang that I've used for quite a while to know if something was actually failing or not. I had every time to open the standard library because everything had the error type in the return. And it's not well typed, so there was no reason, no way to know that upfront. Another nasty thing is it uses internally the console dependency. We see here there's a call to an external module, and that is completely hidden too. So in order to know that this function is dependent on the console, that another time you have to look at the implementation. All of those things makes testing harder, not impossible, but harder. And if you think this is a very small piece of code in a normal day-to-day application that you write, you're gonna have thousands and thousands, if not tens of thousands of lines of code. If all of your code is designed in this way, testing is gonna be a thing that you know it's good to do, but you never actually do because it's painful. And because, well, it takes a lot of time when it actually should not take a lot of time. It should be very easy. It should actually be much faster to write an automated test rather than spin up your program and test it manually. It should be incredibly faster, even the first time. So the actual content of the slides is done, and let's start with a little bit of live coding, and we're gonna address the issues with the hello world function. So first of all, we said it's not a function, we have to make it a function. That means we have to make it return some values rather than performing a side effect. The second part is there is no expressivity if the function can fail or not. We are gonna solve that by specifying this in the return type of the function. And the third part is about making the dependency on console explicit. So as we see from here already, each piece of program have three components. It will need some dependencies to run or not at all. It might fail for some reasons. And in case it doesn't fail, it's gonna produce a result of some type. These three parameters, these three elements are very important to keep in mind because they're gonna be the key of this architectural design. So let's take a look at how do we solve in practice the hello world function. So this is
You probably want to increase the font size a little bit of the
font
editor.
size, yes.
Yeah.
Ha. That's definitely too much. Is enough? Oh, battery is running low. Ouch. 1 second. I'm sorry, but the battery is running low.
All right, that's not a problem. I can try to entertain the crowd in the meantime. It would be no, it wouldn't be funny if your computer died right now. So yeah, I don't want to even joke about it, but it looks like you have it under control. The charger is in reach. We had this with one meetup, I think, in the past, where actually the computer of the host, where like the battery died, and unexpected things happened.
Unexpected things happen, yeah.
All right, you're back. I'll hand the stage back over to you, Michael.
Yeah, I'm back. Sorry about that, but I was running out of battery. So we were saying, hello world function, this is what we start with. So there we go. This is the start. And we said, first of all, we have to make it a function. How do we make it a function? Well, instead of performing the operation directly, we can return a func of code that when executed will perform the actual effect. So in this case, when we have our call, hello world Mike, nothing happens. This is not yet running. And we have from the return type an information that this is a func of code that basically needs to be invoked in order to run. So whenever we want to run it, we'll call it, and the effect will run. The first advantage that we've gained, for example, we might write retry combinators or any other sort of combinators that we can think, because this is now not. If I call this 3 times, it's going to print 3 times. I don't have to reinstantiate the inputs every time. And you can imagine if this was a failable function, then I could gain a lot of power, for example, saying, okay, I have this HTTP call. If it failed, retry that up to 3 times, 4 times, 5 times. And that can be done in a separated way from the function itself. So the first problem, it's easy to solve, and it's just a matter of returning something. Second part, we said there is no information if that function can fail or not. Well, this is still correct. There is no information here. For that, we can use an either data type that, for simplicity, I'm going to import it. So the either data type, we can see has 2 options. It's a union type. It has the left side, which might contain a value, or the right side that might contain a value. If I specify that this function shall return neither of never on the left side and of void in the right side, this is a smaller trick, but at this point, we see from the return type directly that when invoked, this function will never fail or will return a value, an empty value. So there is an effect running. We don't have a return value, but it's specified that this can never fail. And you can imagine this is much more declarative compared to just throwing exceptions that are not present in the type system. So what's left here? The dependency on the console. Now, there are various ways to address these. One common usage is the cake pattern. So I can say I have a console service. And in this service, I have a log function that, taking a string, is going to return the thing that we saw before. This type, you can call it IO, for example. And this is the notation that you will see in, for example, FPTS, if you use FPTS. So we have now a console service interface. Rather than using the console directly, we can access the console from what is called the cake. in the cake pattern. And we can now, we've made this explicit. So from the type, it's clear that this function is going to require a console to run, and it might return. Well, it has an effect that when it runs, it's either never or void. So here we have our call. This time, when we get to actually calling the thing, we have to provide a concrete implementation for this log service. And this is precisely as it was before. This time, it's once we call it again, it's gonna be well. Let's check the return type of this. This is an IO, so we have to call it in order to run it. When we run it, we have our result, which is an either. And if there were any error, they are on the left, either they are on the right. So this is one example on how do we solve all the things. Clearly, that's not a so nice approach. It's highly verbose, and how will you even compose those things? In order to do hello world with something else, and in order to compose it with multiple parts of your program, it tends to be highly verbose. And well, it's not so approachable. But in theory, this is an explicit definition of the hello world function. So something that showcases the dependencies, showcase the fact that this function never errors, and that it performs an effect when it's running. Let's see how with the next part. At this point, clearly the function is testable. It's not good looking, as I was saying. Even worse when we need to combine it with other functions. And we would like to better express the dependencies and the failure type in an actual single type, so the things are going to be looking slightly better. The type we are looking for is, we said it contains three elements. So this is the first time we see an import on effect. And let's look at the type definition of effect. The type definition of effect has three parameters. R, which is the dependencies parameters, so the thing that a program requires has a potential error, so things that might fail, and has a return type. So these is the three elements that we're gonna use. I said this function is now testable. Why? Clearly, you are delegating the definition of a live console to the very end of your program. So in your tests, you can use a fake console, and you can do whatever assertions you want by replacing the console. The program is written in a way that's not dependent on a concrete implementation of the console. It's dependent on an interface. This is a classical method that we encounter many times. Program to an interface, not to a concrete implementation. So how would we do this with an effect? But first of all, we can simplify the code a bit. And we can say that the log function doesn't require anything to run. So it works with an unknown input, doesn't care. It never fails, as we said before. We use the never type, and it provides a void result at the end. For that, we create a service tag. A service tag is a way of identifying this specific service in an environment that might have hundreds of services around. And we can make a utility we access the function, we access the service from the environment, and we use the service from the environment itself. And if we check now at this type, we will see that this is a function that when called will return an effect that in order to run requires a console service. It is an environment that has the console service inside. It never fails, and it will return a void in case of successful execution. So our hello world function can now be refactored by using hello world name, the same story, everything is properly inferred. When we call it, we have an effect that in order to run, so this, we might say it's our program. In order to run the program, we can run it to a promise, and we will see from the type an error, and the error will tell us, look, I cannot find a log function. You're missing the console service. It basically says the default environment does not have a console. So you have to give it a console in order to proceed. You can say provide service, console service. Here you have to specify your log function. This is a message. And we say it's an effect, it's a total effect, so a thing that can never fail. And inside here, we call the actual console. And this program is now complete. There is no longer any type error. And when we run it, we can just double check that everything is correct. It does print out as expected. How do we compose multiple things? Well, let's say I want to say hi to Mike, I want to say hi to John, I want to say hi to Sam. You can chain those elements. And so on and so forth. So that's composition. They compose really well. If you have different dependencies, they will gonna be both required. It's the example we're gonna see in 5 minutes. Or alternatively, you can spoil another feature of TypeScript that we saw before in the previous call. They're called generator functions. The yield type is actually always returning any, even if you specify the types. And specifying the types is not completely nice. Lucky for us, the generator of a generator is actually well typed. It's a fantastic thing, but it might be looking strange if you didn't saw any yield star before. But anyway, think this syntax just like async await, as you would do with async await. It's the same style of programming, but this time the result type is properly inferred on SAM, and this is still purely functional programming, looking imperative rather than functional composition. We now run it, and we'll see Mike, John, and Sam printed out. I might say, repeat that twice. As I said before, this paradigm, we can repeat things, we can retry things, and this is gonna be repeating twice the same story. It's actually 3 times, because it's one execution plus 2 repetitions. And that's how you use effect in basic terms. The next part, clearly it's still everything very well testable, because your services are shifted, they are separated, and so on and so forth. The next point is actually to make a little bit more contrived example, and we are gonna write a program that generates a random number between 0 and 1, depending on the number generated. If it's more than half, we're gonna print out what we've got. If it's less than half, we're gonna refuse with a well-typed error. So first of all, as we've seen here, first step is to actually declare a random service. The rand function that cannot fail, and will return a number. We declare a tag, like we've done before, and we declare an access pattern, as we saw before. Some service, and just invoke the rand. Service, not random source. There is a random source in TypeScript, so that's the reason why it was not working. This we see it requires a random service. So let's say that our program now wants the value, random value. We generate a rand, a number, and we say if value is greater than 0.5, then this thing is gonna fail. We want a typed error at random value. For simplicity, I always advise to make the errors tagged, so to specify a discriminator, because when you're going to have multiple errors, you're going to end up with a union of potential errors. It's going to fail for reason A, B, C, D, or D. And having the discriminator makes managing the errors much easier. So we say t.fail, new, bad random value. You can see from the type itself that this is now a failable effect that requires a random service to run, or can fail for a bad random value. We said if the value is less than a half, we want to print out that. And we're going to do like before. We're going to print dot value. And now checking at the type, we're going to have an effect that requires random service and requires console service in order to be performed. We see the error type as previously, and this time it's going to say, yeah, I cannot find the random service inside the default environment. So like before, we have to provide the random service. And as before, it's an effect that can never fail. And return math.random. This is a pseudo number between pseudo random number between 0 and 1. Let's just remove that. And let's see if it should either succeed or fail. The reason it's an unhandled promise rejection that has failed. It's not a nice way to do things. Promises throw exceptions. We can run it to an exit that is a safe exit value, and this can be either a failure or a success. But much more interestingly, we can take a look at there's a special runtime for node.js. That by default links to interruption. So if you shut down the service, all whatever is going on is going to be safely interrupted. The library contains structures to manage resources. You can manage database connections and much more. I have to say the library itself has more than 10,000 different functions and combinators inside it. So that's much more than what we can go on in a small talk like this one. The documentation of Zio is a very nice documentation that showcases all the types that are available. But let's see what this run main does. It's gonna be probably now if it's 1.5. It's still an error. So we say we have this checked exception. We've got this number and it was not a valid one. And then you have a really nice trace of what's going on. If I click here, you can say it points precisely to the thing that went wrong. And if this is enabled in production, when thing fails at scale, it's nice to see that it basically goes over the full, well, it shows the full path and it picks precisely the points of failure. So you have nice stack traces. But we don't really like for this to fail a lot. It's a flaky service. So let's say we want to retry. And we retry here, we see it takes a policy that specifies what retrying means, specify a schedule, that there is another data type, that defines the schedule. And we can say very basically, we want to retry, want to recurse 10 times. So this is going to retry up to 11 times, including the first invocation. So now most likely it's going to succeed. Because out of 10, it's a high probability. And in fact, it is succeeding. But let's say that retrying n times is not enough for you, or you might want to have some weights between one call and the other. If you're, for example, calling an external API, so you could do an exponential backoff, and this is now retrying over an exponential backoff. You might say, I want to retry with an exponential backoff, but only up to 10 times. Functional programming is nice because it's declarative and composable. So you can build very complex schedules that basically define exactly how you're going to retry things or repeat something else. So as we see now, this still
quick
passes.
interruption, Michael. Sorry to interrupt.
We're running out of time.
Close to the end time of the meetup. It's of course not a problem. I just wanted to remind you that it like maybe makes sense to like wrap up soon, so that we don't go too far over time.
I'm just gonna the last few minutes. I'm gonna write the test for this because it's testable code. Otherwise, it's pointless. So how do we test this? Clearly, there's an invocation. This is an impure file. You want to separate your actual code from the invocation place, so you can test out your program easily. While this is your main file, your actual dependencies, and your invocation goes here. And then in the test thing, we can say import no, it's app main should raise 4 numbers less than 0.5. Actually, it's great. Should greater than 0.5. It's going to be an asynchronous function because the effect is always asynchronous. It's backed by a fiber execution model, so it handles concurrency and many other things. And let's actually take our real invocation. We don't want to retry here. We need to import the dependencies. Salt service, random service. And this time we want to run a promise of an exit value, so we don't fail stupidly in the test. Clearly, we don't want to print out anything in the console, so we can make string array and just push message here. And we want to test greater than, so 0.51 as a random number for test is going to be nice. And we want to assert we are expecting the result to be a success, actually to be a void, so it's a unit, and we are expecting the message. It's actually, this should succeed. I'm gonna do the raise part later, less than 0.5. That it should succeed with a unit, and the messages should equal to an array of got 0.49. Let's try to run this. It is also compiling, it passes. So this test went well. Let's say number greater should raise, pretty much same story. And this time we wanna say that the exit is gonna be a failure. It's not exported precisely. A bad random value, 51. And given I'm actually tracing the application, I have to say I want untraced execution. Otherwise, I'm gonna see, as before, many other information in the error facility. Let's take a look here. This is failing, of course, because I don't have a message given in the failure case. Both tests pass, and we are done with it. We have tested both cases. I have to add, in effect, you're gonna find many other data types. Providing services one by one might not be a good idea. In general, layers are the thing you wanna look at. Like for schedules, they are a specific data type, this time to provide environment and to construct environment. So you have a very declarative way. For example, just from this, instead of doing this, we could say, just gonna take 1 second. Just taking it from here. Okay, that this is a test console. Test random. Just copying things now. Have these two layers, and you can say provide some layer, provides a layer to the given effect, and I can say test console together with test random. And you can, of course, have huge trees of interdependent things. +++, there is one dependent on the other, and many combinations that you will have to learn on how to construct and compose services. but at the end, it's the same story. But now those can live wherever. You can organize the code however you prefer and still have everything testable and working in the same way. Well, I've skipped some slides, but the idea is that one. You have many packages in the ecosystem that are all built around those principles. Just to name a few, we've seen core, and system is the internal part of core. Here there are around 35 different data types that are each taking care of some specific aspects. This is like the core library. We have a tracing plugin, that's a compiler plugin that adds the execution trace information to your code. This has no runtime cost because the traces are added at compile time. We extend the TypeScript compiler to do that, and the tracing utils that are used to enable or disable testing in live mode, so at runtime. That's the compile time and the runtime part. We saw the node integration. If you're running in node, you want to take care of shutting down things if your service gets interrupted, and a number of other things. This does it automatically. Effects are interruptible, so you can kill a running effect, not like promises that when they're running infinitely, and you cannot stop them. Monocle provides functional lenses, so access to data structures, read and write on data structures. Morphic provides runtime types and type class derivation for things like equal, show, and other type classes. Query is very interesting, and it's going to be the basic of one of the future packages that we're going to make. It's going to be a GraphQL package. Queries for pipelining and batching of queries. It has support for multiple data sources and user-defined queries, so you can be efficient in data fetching across multiple data sources with caching and with all the benefits of never duplicating. So you have batching, pipelining, and everything else. Express is a small wrapper around Express.js in order to build APIs and backend services. And the last entry that we have in the ecosystem is Printer. That is a combinator library to text manipulation, document manipulation, and rendering. And it's really nice. Don't have time to speak about that, but it's definitely a nice thing to take a look at. That's the whole ecosystem for now. We have many more things to come. And as I said, the core package alone contains around about 10,000 different combinators. So the thing is much, much bigger than what I was able to show today. Hopefully in the workshop, we're going to take a look at those aspects in much more details, and we're going to build some live running applications. So thanks everybody for having listened to me. And I'm sorry I had to spend 5 more minutes, but I had my unfortunate battery event before, so I've lost 5 minutes there.
Michael, thank you so much. That was incredibly insightful. And Effect.ts looks really, really awesome and really powerful. And to be fair, I think that was the most powerful Hello World function that I've ever seen in my life. So kudos to that. And it was really well explained. So really nice talk. Thank you.
Thanks.
And
Thanks,
for the record, for everybody who's watching, I just want to make sure that you're aware that this course of this entire video, of course, will be up on YouTube afterwards. So even if you have to drop out at some point, you can, of course, go and watch everything later as well. We don't have time to pick the questions right here on the stream, but there, I think, were 4 or 5 questions that have been asked, Michael. So while you now go backstage again, you can take a look at these questions and let us know who should be the winner of your functional programming workshop ticket. And we'll announce it towards the end of this stream today. So thank you so much for joining us today, Michael.
Thank you. Cheers.